multiplying and dividing decimals by powers of 10, 10, 100, 1,000. So powers of 10 makes this actually really easy. So every number can be written so it contains a decimal point, even a whole number like 345. 345 and 345 and 0 extra bits, or parts of their 0.0, same. You can write extra zeros and not actually change the value, but there will be a time when that actually is necessary. It makes sense. I like to think of it's 12.5. You could think of that as $12.50. What does that zero mean? That makes more sense for money. When multiplying by powers of 10, it's pretty simple. You are going to, what we would say is, move the decimal point to the right by the number of zeros in the multiplier. The fact is, really, the decimal point stays still and the digits hop across, I would say, the decimal point. But for simplicity's sake, we say if we're multiplying by 1,000, we've got 1, 2, 3 zeros, so our decimal point is going to appear to hop across 1, 2, 3 places to the right, which you can see there. When you're dividing, guess what? You're going to move to the left by the same number of zeros in the multiplier. If we divide by 100, 100 has 2 zeros, so our decimal point compared to where we started is going to move back 2 places, or our digits are going to hop across so that it appears the decimal point moves back 2 places. Here we go. So always, we can check this with a calculator. 36.532 times 100, let's just check again. Times means move to the right. So our decimal point is going to go whoop, whoop, because we have 2 zeros. So that gives us 3653.2. We don't need any extra zeros at that point. Now this one, 4.31. We're going to need some extra zeros because we have 4, and then we're going to jump 1. That's 1 0. We're going to jump another 1. That's 1 0. And then we have to make 2 more jumps. So 4.31 times 10,000 is 43,000, which kind of makes sense. You had 4 wholes times 10,000 is 40,000. And those other bits are going to stay in there because we've hopped our decimal, or we've hopped our digits across the decimal point according to that 4 times. Dividing, we're just going to move to the, let's just make sure, we're going to move to the left if we're dividing. So if I have 68.15 divided by 10 is 1 0. So I'm just going to hop back 1 and get 26.815. Again, there's no shame in taking out your calculator and just making sure. This is where lots of mistakes happen, when we've got powers of 10 and zeros are flying all over the place and decimal points are moving. So this one we're dividing by 1,000, which has 3 decimal places. So we move 1, 2, 3. So we have 0.00782 because we started with 7.82, and we'll just check. We had the point there. We moved 1, 2, 3, and that's where we put our extra 0 at the front just to make sure that we know we've got nothing, and 0.00782 after the decimal point. Evaluate the following. So 567 times 10,000. We have 4 zeros, so we have 567 plus 1, 2, 3, 4 zeros, and we can put our commas in there to make it a little easier to see, but that is the answer. We're now dividing 23 by 1,000, which is 1, 2, 3, and 23 actually has, like 567 had, an invisible decimal point just there. Just like we saw with the whole numbers up the top here, 345 and 345.0 are the same thing. That decimal point is off to the right, just sitting there. So now we're going to move it. We had 3 zeros, 1, 2, 3, which requires that extra 0, so we'll call it 0.023. Calculate this expression using the order of operations. Now the order of operations, just to remind us, could be BIDMAS, could be BOMDAS, but we're remembering that we do brackets, indices or orders, then from left to right, multiplication or division, look how they're different, and then from left to right, addition and subtraction. So we're going to look at this first. So we're going to copy down 426, divide 100, plus 10 times whatever's in those brackets. And so I have 0.43 times 10. Well, that's going to give me 4.3 minus 1.6. So that's my first operation. And then I'm going to put my equal signs, and again, divide by 100 plus, I haven't finished it, 4, remember I line up my decimals, minus 1.6. Got to borrow one from there. That gives me 2.7. 10 times 2.7. Okay, now it looks like I would do brackets next, but the reality is I can do this and this at the same time, because as long as I do my multiplication division from left to right, so 426 divided by 2 zeros gives me 4.26, and then I do the other multiplication division, because I'm not ready to do my addition and subtraction yet. 10 times 2.7, well, if I'm doing times, that will make 27, because that moves to the right, the decimal. Then now I can add them together. So let's move over here in the weeds. 27 plus 4.26. This is where I could add my additional decimal points just to make sure I don't, just to ensure accuracy. 7, 8, 9, 10, 11. My answer should be 31.26.